The next is Mendeleev periodic table. See, the rejection of Newland law of octaves, many scientists continue to search for a pattern that correlated the properties of the elements with their atomic masses. Here, the main credit for the classifying elements goes to the Mendeleev, that is the Russian chemist. He was most important contributor to the early development of the periodic table of the elements, wherein the elements were arranged on the basis of their fundamental properties. See, that's mean atomic masses, atomic number, also that is the similarities of the chemical properties like this. When the Mendeleev started his work, that is 63 elements were known. So here this is the Mendeleev's periodic table where the 63 elements are discovered. That's mean known. He examined the relationship between the atomic masses of the elements and their physical and the chemical properties. So among the chemical properties, Mendeleev concentrated on the compounds formed by the elements with oxygen and hydrogen, because many of the elements react with not all the elements react with oxygen and hydrate. That means they forms oxides and hydrate. For Mendeleev periodic tables, here the R2O, RO, R2O3, like this. The similarly hydrogen react with the hydrogen, they form hydrates RH, RH2, RH3 like this. So here the chemical, that is the selected hydrogen and oxygen, they are the very reactive. That's why they choose. They are very reactive and formed compounds with the most elements. So the formula of the hydrates and the oxide formed by the element were treated as one of the basic properties of the element for the classification. So he then took 63 cards, and on each card he wrote down the properties of the one element. He sorted out the elements with the similar properties and pinned the card together on a wall. He observed that most of the elements got a place in a periodic table. So and were arranged in order their increasing atomic masses. So increasing atomic number, then increases atomic masses also. It was also observed that there occurs a periodic recurrence of the elements with the similar physical and the chemical properties. So on this basis of the Mendeleev formulated of a periodic table, which is the properties of the element, periodic functions are their atomic masses. So this is the Mendeleev periodic table law. That is, the Mendeleev periodic tables contains groups and the periods. See, the vertical column is called groups, and the horizontal period is called the horizontal row is called periods. The vertical column is called group and the horizontal row is called periods. So this is group 1, group 2, group 3, group 4, group 5, group 6 and group 7. Here the group 8 I wrote here, the group 8 elements. Then oxide, that is periods, totally 6 periods, 1, 2, 3, 4, 5, 6. Here also the 4, 5, 6 for group 8 elements. Look here, the achievement of the periodic table, mainly here the R indicates means any element, that totally 63 elements are present here. Any elements react with oxygen, any element react with hydrogen. For example, carbon react with oxygen to form carbon dioxide. Carbon react with hydrogen, for example RH4. This must be a carbon, means supposed to be this R may be carbon, they form carbon with 4 hydrogen atom, that is methane. Here carbon react with oxygen, that means 2 oxygen, means that is form carbon dioxide. So this rows oxides and this is called hydrates. That means they forms oxides and hydrates, and they group 1A and group 1B, similarly 2A, 2B, like this up to 7A to 7B, then 8th group like this. 8th group does not forms hydrates, only forms oxides. Then the achievement of the periodic table, that is Mendeleev periodic table, there is a few instances where Mendeleev had to place an element with a slightly greater atomic masses before and element with a slightly lower atomic masses. That means the sequence was inverted so that the elements with the similar properties could be grouped together. So for example, here cobalt and nickel, that is, they have the mass number is 58.93 for cobalt, 58.93, and the nickel is 58.71. But the higher atomic masses placed before. Then next is the 58.71, that is the nickel. Like this, the arrangement was like this. So here, that further, that is, the Mendeleev left some gaps in the periodic table, like here, so that here some gaps in periodic table. Instead of the looking upon this gaps of defect, that is, Mendeleev boldly predicted the existence of some elements that had not been discovered at the time. Okay, then the Mendeleev named them by prefixing of a Sanskrit numeral, that is Eka. Eka means one. So that is the name the proceeding element with the same group. For instance, the scandium, gallium, and germanium, they are discovered later. They have similar properties like Eka boron, Eka aluminum, Eka silicon, respectively. This properties of Eka aluminum predicted by the Mendeleev here, predicted by the Mendeleev, and those of the element gallium, which was discovered later and replaced by Eka aluminum. See here, the atomic masses of Eka aluminum and Eka gallium, Eka aluminum atomic masses, Eka aluminum, the atomic masses 68, and gallium 69.7. The formula of oxide, for example, E indicates element. So here aluminum means that is E2O3, for example, Al2O3, the formations of the oxide or formula of oxide. The similar way here gallium oxide, that is Ga2O3, that means the similar properties. Then formula with chloride, ECl3, for example, element with chlorine, that means AlCl3, Eka aluminum, that is chloride. Then similar way gallium chloride, 3 chloride. This provided the conveniencing evidence for both the correctness of the usefulness of the Mendeleev periodic table. Further, it was the extraordinary success of Mendeleev's prediction that led chemists not only to accept the periodic table but also recognize him as the originator of the concept on the which it is based. So noble gases like helium, neon, argon have been mentioned in many contexts before this. So these gases were discovered very late because they are very inert, that means chemically unreactive, and that present in extremely low concentration in our atmosphere. That is why they chemically unreactive. On the strength of the Mendeleev periodic table was that when these gases were discovered, they could be placed in a new group without disturbing the existing order. The limitations of the Mendeleev periodic classification or the Mendeleev periodic table. The electronic configuration of the hydrogen resembles that the alkali metals. Like alkali metals, that hydrogen combines with the halogen. The hydrogen combined with halogen, that means halogens mean HCl, HBr, Hi, HF, whatever it is, combines with halogen, oxygen and sulfur, H2O, like this. HCl, compounds of hydrogen means there is oxygen react with sulfur, that is like alkali metals, hydrogens combine with halogens, oxygen, sulfur to form the compounds having the similar formula like NaCl. here the compounds of sodium alkali. Alkali metals means sodium chloride. Similarly, sodium oxide Na2O and sodium sulfide Na2S. They are similar. So on other hand, just like the halogen, hydrogen also exists as a diatomic molecule. Halogens also, simply we can write like this: halogens, chlorine, fluorine, chlorine, bromine, iodine. Simply they are diatomic molecules. And hydrogen also exists as a diatomic molecule because hydrogen, the formula is H2. It combines with the metals and non-metals to form a covalent bond. Usually they forms a covalent bond. Then certainly no fixed position here. The hydrogen, now the long form of the periodic table, hydrogen placed in the first, but they are placed in the metallic series, that is group 1 elements. But in Mendeleev they didn't give places for hydrogen, that means he didn't give. So certainly no fixed position can be given by hydrogen in the periodic table. This was the first limitations of the Mendeleev periodic table. So he could not assign a correct position of hydrogen in his table. That is the drawback one. Then the isotopes. The isotopes were discovered long after the Mendeleev had proposed his periodic classifications of elements. Let us recall that is, isotopes of an element have similar chemical properties but different atomic masses. The same atomic number, different mass number is called isotopes. Simply for carbon, hydrogen 1, hydrogen 2, hydrogen 3, like this. Then the isotopes of all elements that possessed a challenge to Mendeleev's periodic law. That is, another problem was that atomic masses do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between the two elements. So especially when we consider the heavier elements. So he discovered, that is, totally in Mendeleev periodic table 63 elements were discovered on that time. So next, the modern periodic table we will discuss in next class. Thank you.